So for starters, let's look at this function. It says 3x squared minus 4 for x less than 1. So what is happening for this function, 3x squared minus 4? So it's going to look like this, 1, 2, 3, 4. And if I plug in 1 to that, I'll have 3 times 1 squared minus 4. So that's going to be at negative 1 when I get to 1. So I'm going to put an empty hole there. And it's some sort of a parabola thing going like that. Okay. And then when x equals 1, the function is valued at 2. And then we have 6x minus 7 for x greater than 1. So if I plug in 1 into that, I'll have 6 times 1 minus 7, which is negative 1. So this is going to be a line with slope 6. So it's going to be pretty steep. Going up like that. Okay, so the next thing it asks is which of the following statements are true? Does the limit as x approaches 1 of f of x exist? And so the answer then to that is, as I come in from the left and right to this function, what happens to my y values? So my y values, as I come in from this direction, my y values are getting closer and closer to negative 1. And as I come in from this direction, my y values are getting closer and closer to negative 1. So that limit exists. So this is a yes. Does f of 1 exist? Yes. F of 1 is 2. Is f continuous? So for f to be continuous, both of these things have to exist and they have to be equal. But I know that the limit is negative 1 and the function value is 2, so it is not continuous. So this is a no. So the answer is B, 1 and 2 only. The next one I have, this expression is the derivative of what function? All right, so if I look at this, I can kind of pick out this part looks like f of x, x plus h, and this is minus, and then this part here is f of x over h. And so this is the derivative of the function f of x. So this is the function that we're looking at. So it's going to be x cubed minus natural log x. So the answer is D. And I knew that this is just the definition of derivative. So it's going to be f of x plus h minus f of x over h. So the f of x is that thing. If f and g are continuous functions with f of 5 equal to 5, and the limit as x approaches 5 of 2 f of x minus g of x is 6, find g of 5. Okay, so the f and g are both continuous, so I know that the limit as x approaches 5 of 2 f of x minus g of x, well, if they're both continuous, then that means that limit is just the same as the plugged in value. So that's going to be 2 f of 5 minus g of 5. And I know that f of 5 is equal to 5. And I know that this limit is supposed to be equal to 6. So now I can solve this equation for g of 5. So I have 10. I can subtract that over. I get negative g of 5 is equal to 6 minus 10, which is negative 4. I can multiply both sides by negative, and I get g of 5 is equal to 4. So this is the answer right here, A. So next we have, if g prime represents a child's growth rate in pounds per year, which of the following expressions represents the increase in the child's weight between years 2 and 5? And so I think that the thing here is that if g prime of t is the child's growth rate, that we know that the integral of a rate is the net change. So if we integrate that rate function from 2 to 5, we'll get the net change. So that would be A. Okay. And by the fundamental theorem of calculus, this is equivalent to, if I take the integral of g prime, that's g of 5. minus g of 2. So it almost looks like the answer for B, but B has the primes there, so that's not the integral of the, is not the antiderivative of the g prime function. Okay, and then the last one says a portion of the graph passes through C f of C is shown below. Which of the following conditions are satisfied? Okay, so let's think about, so it's asking about the first derivative and second derivative. Okay, so for the first derivative, f prime of C is, well, since it's sloping downwards, the slope is negative. So f prime of C is negative. Okay, so I can just rule out the ones that say positive right away. So A and B are gone. And then let's look at f double prime. So for x on this side of C, so for x less than C, the function is concave up. So f double prime of x is greater than 0. And when I am to the right, so for x greater than C, then the function is concave down. So f double prime of x is less than 0. Okay, and so which one is that? F double prime is greater than 0 for x less than C. Okay, so that ends up being C. And f double prime is less than 0 for x greater than C. Yeah.